In the last exercise, you plotted column charts, pie charts, and line charts using a budget worksheet as your data set. That data set was relatively small. Now we'll move on to analyze and charting larger sets of data. We'll recall that our goals for charting data are to improve understanding of the underlying data or real-world system, to highlight differences, trends, or anomalies, to support conclusions or predictions, and to spot potential problems. There are tens of thousands of real-world systems from every area of academic, professional, technical, or business pursuit. We have solar, climate, financial, energy, geological, neurological, and zoological systems. We have markets, commodities, and pricing. We have judicial, medical, and social systems. All of these systems have data. We must be able to interpret that data. To study any system, we must first unbiasedly gather its data. Second, we apply data analysis techniques. We use a mathematical or computer model, import into Excel, chart results, interpret those results. Third, and very importantly, we must verify that our interpretations or predictions are accurate by comparing them to subsequent real observations. Our data analysis goals are very similar to our charting goals. We're trying to better understand a real-world system. We want to highlight differences, trends, or anomalies, or make predictions about future behavior, or help in decision-making. Let's look at one real-world example, climate and temperature. This is a real-world system with readily available data, easily downloadable from the internet. We'll import the data to Excel, chart the results, and identify any trends. There are several major sources of temperature data, including from the Goddard Institute of Space Science. Detailed instructions for how to download this data and chart it in Excel are included in the Excel assignment file, Climate Data Charting. At the Goddard website, you will scroll down until you find the world map. Click on any point on the map to see a list of nearby temperature stations. Here's Stuttgart, Germany, or the South Africa station, Antarctica, or Johnstown, Pennsylvania. Scroll down further on any of the local maps and click on Download Monthly Data as Text. Here's a view of the detailed data for Johnstown. You will copy this data and paste it in Excel. I'll go through this example using Excel in a few moments. Once we have the data in Excel, we can chart it, adjust the scales on each axis, and add trend lines. The linear trend line, shown here as the straight red line, shows a general pattern of cooling over 120 years. Linear trend line smooths out a great deal of variation and is not always the best fitting possibility. Here's the same Johnstown data with a polynomial fit trend line, the smooth, curving, thick red line. This trend line probably better demonstrates the natural cycle of rising and falling temperatures. Remember, charts are just dumb pictures until we tell their story. The title should highlight, identify trends, support conclusions, or identify problems. Here we've added the title, Johnstown Annual Average Temps Vary in High and Low Cycles.